All right, I misspoke right at the end there. It shouldn't have been the nth derivative. It's the n minus 1th derivative goes up to the m minus n. Or if it's more convenient for you to think about the nth derivative, then it's just to the m minus n minus 1 right there. So, not that I think you should memorize that formula, just you should know that's the general shape of what comes out of the leading coefficient. So our next example is going to be to solve 4x squared y double prime plus 8xy prime plus y equal to 0. And so right away, you might be able to say, okay, I think I'm going to end up having to have something like 0 equals 4 times m minus 1. That gives me up to the second derivative plus 8m plus 1, like that. And we're going to go through the steps to kind of like make sure that we know that that's what actually happens here. And those steps come from just guessing that y is equal to x to the m. So y prime is m x to the m minus 1, and y double prime is m times m minus 1 times x to the m minus 2. So then we need to have 0 equal to 4x squared y double prime plus 8xy prime plus y would actually be 4x squared times y double prime is right there, m times m minus 1 times x to the m minus 2 plus 8x mx to the m minus 1 plus y is just x to the m. And I have to just start simplifying this. So I've got 4m times m minus 1. It's a bad minus sign. And then my x squared and x to the m minus 2 multiply together to give me x to the m. I've got 8m x to the m when my x and x to the m minus 1 multiply together. And then that single x to the m stays the same. And then we're going to have, we've got 4m times m minus 1 plus 8m plus 1 all times x to the m. And we want that equal to 0, so what we're trying to solve is 0 equal to 4m times m minus 1. I'm going to do that in the next line. Plus 8m plus 1. So when I start to multiply things out, I've got 4m squared minus 4m plus 8m plus 1. So that's 4m squared plus 4m plus 1. And so if I want to try to factor that, I'm probably going to need a 2m out front of both these. Would have to have a 1 to get that plus 1 at the end. And this will turn into 2m times 2m gives you 4m squared. 2m times 1 twice gives you the 4m, and 1 times 1 gives you plus 1. So that is how we factor this problem. So the roots are m equal to minus a half, repeated. Since they're the same roots right there. And so since I found repeated roots, I go back to my list of ways I solve this type of equation, and I found repeated roots. So what I do is, to get enough solutions to form my general solution, second order needs 2 solutions, I start adding on powers of natural log x until I have the amount of solutions I need. So that's going to look like y equal to c1 x to the minus a half is the first one, just from looking at m equals minus a half. And then I have c2 x to the minus a half times natural log of x. And that's the general solution to this problem. Something that is kind of cool is, well, I won't write it, but technically you could derive x to the natural log x is a solution from x to the minus a half is a solution. So I told you, like on this slide right here, that if you find repeated roots, this is how you find the solutions. But if you had repeated roots and you were sitting there and you said, I only found x to the minus a half, what do I do? Our first section in this chapter, reduction of order, would have taught you that if you assume y2 is x to the minus a half times some unknown u, that unknown u would actually be natural log x. So reduction of order is actually how we know that that second solution works. And if I have time after recording all the examples I want to see, I might do that derivation at the end of all this. But if not, just know that you can do that.